approach, where all the 5 modules, okay, same situation, all the 5 modules will be tested individually, independently, without being combined. So let's assume I have module A until E. So each of these module will be tested individually, A individually, B until E. Then we will combine all these 5 as a whole system. Then we test. Okay, so there is different approaches here. Okay, so let's see how they work. Let's start with the incremental first. Okay, so the diagram is actually showing the hierarchy of the modules of a system. Okay, so we have module A on the first one, and then the second level is B, C, and D, and then we have the third level, which is E and F. Okay, so when we set incremental approach, okay, so we actually test a module and then we will combine with the previously tested module. Okay, so later I will discuss about this driver and also stop later. Okay, so every time when we want to test using incremental approach, we always have a strategy which we can choose to use. Okay, either we want to test from from top to down, or from bottom to up. I think you have discussed this during your software engineering before. Okay, let's see how this strategy works. Okay, this one. So we have 2 different strategy which we can use. Either we want to use top down strategy. It means I start from the top level, okay, the highest level of the hierarchy, and then I move down to the last one. Okay, and the second strategy is bottom up. So it means I will start the integration from the lowest level of the hierarchy, and then I will move higher level. Okay, so something like this. Okay, so let's assume this is a hierarchy of a software. Okay, so A is the highest one, and then J, K, L is the lowest level. So we have 4 different levels here. So when we say top to down, it means we start from the first highest level, which is this A, or we can say it as a main module, move down to the sub modules until the last terminal module. Okay, so that is top to down. Okay, and the second strategy, bottom up, it means we start from the lowest level modules, or we call as some terminal modules, and then we move higher. Okay, clear about these strategies, how the top down and bottom up work? Clear, everyone? Please do let me know if there is anything you are not clear with. Okay, so when we set incremental approach, okay, we always need to decide how we are going to do the combining activity. Are we going to start from top module and then move down, combining them, or we want to choose the second strategy where we start from the bottom level module and then keep combining them until the highest level. Okay, so in your programming before, I believe you have discussed about drivers, you have discussed about stop. Any idea about what is this driver? What is this stop in programming? Anyone? Driver, stop. Have you heard this before? Have you used it before? It's in programming. Maybe have you heard dummy code? We need dummy code for testing purpose. Have you guys used that? Please, do let me know. Do respond me. I don't want to be talking alone, please. Have you guys heard about dummy code just for testing purpose? No. Okay. So actually, this is more onto coding, coding side. Okay. So we will use this stub and driver when we are doing integration. So it means while this development is carrying, okay, because we do integration while we are doing the development of the module, development of the functionalities. So when we want to do the integration and to proceed with the testing, okay, if there is needed of code where we have not complete the coding yet, so we might need to use dummy code. Okay, so when we want to use this dummy code, especially in this incremental approach, we need to decide either we need driver or we need stub. Both of this keyword, okay, if you see stub, okay, and also driver, both of this, they are actually referring to dummy code, but the terms being used here is actually indicated based on when we will use it. So that's why there is two different naming here. So when we are using top to down strategy, it means I start with the main module and I move down to the lowest level. So if I need to use any dummy code during the integration, I will use start. So it means I have started or I have my main module completed, but my lower level module is still in a process. So while I'm doing this integration, I need this dummy code to replace it for the testing purpose. So when we use a dummy code in the top-down strategy, we call it as a stub. So this stub will be replacing the lower level module to be called by the main module. Okay. So on the opposite side, when we do the bottom up strategy, it means we already completed the bottom part. So this strategy based on where we have completed and where we can start the testing. Okay. So when it comes to bottom up, it means we have done the lowest level module. So we will start from there. So whenever we need a dummy code, okay, to be replacing the higher level module to test the lower level module, we will use the driver. So this driver will be replacing higher level module, then it will be used to call the lower level module. Okay, so when we use these approaches to do the integration, we might need this dummy code in case the coding is not completed. Okay, but if the coding is completed, then we might not need this dummy code. Okay, so both of this driver and stuff, they are dummy code, but it's just that the level where we are using, the situation where we are using them, differentiate with the terms. Okay, so this is about the strategy. So when we said incremental approach, okay, so just now we talk about the incremental approach. So we always need to decide either we are going to start from top, it means start from module A and move down to E and F, or we want to use bottom up strategy where we start from the E and F and then going up to the main module. So this strategy based on the completion of the programming or the development. Okay, so the example which given here is where we start from the lowest. So you can see we start from the E, C, and F first. Okay, so this is actually the lowest level for this branch, for this what we call like This is one branch, this one, right? So C is the lowest level here. So E, C, and F is actually will be tested first. Then after that, followed by where B and E will be combined. So when I want to test my module B, I will combine it with E. And when I want to test my module D, I will combine with the previously tested F. Okay. Then lastly, all this will be combined when we want to test the module A. So this is using bottom up approach, bottom up strategy. So if it's top down, then we will start with the A, then we will combine B, C, and D with the A, and then we will combine the E, we will combine the F. Okay, so since here the example using bottom up strategy, so we will be using the driver. So it means whenever there is a dummy code needed, we will use the driver because we need this dummy code to replace the higher level module so that it can call the lower level module. Okay, got it? Clear? So if we are using the top down strategy, then we might need the stub to replace the lower level module to be called by the higher level module. So driver will be calling the lower level module functions while stub is actually being called by the higher level module. Okay. So that is about incremental approach. Okay. Then back to the non-incremental approach. So when we said non-incremental, there is no combining of module happen. It means like how non-incremental combining level by level, there is no combination happen in that way. So for non-incremental approach, what will happen is each of this module will be tested independently. It means one by one will be tested individually. Okay, so whenever we want to test this module individually, based on the hierarchy, we need to have dummy code also to be replacing the higher level module and also the lower level module for that testing purpose. So compared to incremental approach, non-incremental approach will need driver and also stub. Both of it will be needed. So for example, I want to test module E. So since the E is the lowest one, I might need a driver to call these E functionalities for me to test. So let's assume I'm testing by, module B. Module B is actually in the middle of A and also E. So in that case, for me to do the testing, I need a driver which will be act as a module A, and I need a stub which will act as a module E for me to do the testing for the module A. So compared to incremental approach, when we have a strategy to follow, non-incremental, there is no strategy because each of this module will be tested individually, then all these module will be combined and test as a whole system. That is the difference between incremental approach and non-incremental approach. Got it? Clear? Can understand the difference? So incremental means we are combining small sizes first and then make it bigger, bigger, bigger. until the whole system. That is incremental. Okay, like incremental model. Okay, but when we set non-incremental, there is no small sizing combining happen. So we test them individually, then we put them all together as a whole system and we test them as a system. So that is the main difference of incremental approach and non-incremental approach. Okay. So another big difference is the usage of the dummy code during the testing. Okay. So this is about the driver and stuff. So both of them is actually dummy code, but it's just that the purpose when we are using them is actually at different level. So that's why we have a different naming here. Okay. So driver and stop used to replace the missing software and simulate the interface between the software component in a simple manner. So we need them for testing purpose in case if there is any missing software code happen. If no means we will not need. So as part of our testing criteria, test entry criteria, we need to check this. In case if we want to do integration testing, we need to check if the development of the code has been completed or not. So if it's not completed, then we need to generate the dummy code. So that can be part of the test entry criteria which we need to check. Not only documentation, not only test cases. So whenever we do different type of testing, then our test criteria also will be different. Okay, so this is just an example. Okay, so when we will use the driver, when we will use the stopper. So it's a simple component. So we have component A, we have component B. So if you see we have done or we have completed component A, then we need stop. And if we have completed component B, we need driver. Okay, so A is actually calculate the total marks. So calculate total marks is actually higher level than calculate marks for individual particular subject. So B is lower level, A is higher level. So I need this lower level marks first, then only I can do the total calculation. Okay, so the scenario one, when we have finished B, so it means we have completed the component B, where we able to calculate the marks for each individual subject. Okay, but we did not complete the code for the component A yet. So I want to test if it's working accordingly or not. So we create a dummy code, which is the driver, to call this uh, component B, because I need to do the testing. I need to integrate them. So I cannot wait until the code will be completed. So I use the dummy code to integrate and test. Okay. So the second scenario, the same thing, but we have completed the component A. It means the functionality to calculate total marks has been completed, but the calculation to calculate individual course or individual subject marks is not completed. So what we do, we use the stop. It means a dummy code at the lower level so that the module, the component A can call the stop. Okay, so driver it at the higher level will be calling the code. Okay, will be calling the lower level code, while stop is actually at the lower level and will be called by the higher level module. Okay, so that is the difference of this dummy code where we use them. Okay, so they actually being used at the different level. So one is having the higher level where it will call the level code, while stub is at the lower level, so it cannot call, but it will be called by the higher level modules. So that is the difference between stub and driver and when we will use them. Okay, so any question so far about the incremental, non-incremental approach, the two strategy, top down and bottom up, and then the two dummy code, which is the driver and the stub. Clear? Everyone okay? So far so good? Okay, that's great. Okay, so this is about V model. Okay, so as how we have other software development model, so we also have this V model. Okay, so this V model is actually giving importance on software testing. It means testing activity. Okay, so if you still remember yesterday during the tutorial, we have discussed about doing the testing at each stages in the software development life cycle. Okay, so the same thing goes when it comes to V model. Okay, but it gives importance on what we produce at a certain level to be used to prepare for the testing later. Okay, so this V model is actually stand for verification and validation model. So it will do verification at each level, and also it will do the validation later. Okay, so if you see, we have the analysis stage, we have the design stage, and also we have the coding stage. So what we prepare at each of these stages, actually what we needed for our different level of testing later. Okay, so if you see, when we have a requirement which we have gathered, which we have documented, so this requirement will be used to develop the acceptance test later. Remember yesterday we were talking of how we are actually going to confirm on the requirement. So during the acceptance testing, when the end user conduct the acceptance testing, they will check if it's correct according to the requirement which we have documented. Okay, then the design documentation or the design which we have created will be used to develop the integration system test. So it means based on our architecture, what we have choose, how we are going to integrate the system, which module integrate which with which module. So all this is actually the system design. So what we produce during the system design, it means our design document will be referred to prepare for our integration. So it means to confirm if the integration has been correctly done or not. Okay, then during the coding, so it means we have the source code, we have the functionalities, we have the modules what we develop, right? So this will be used for component test or to conduct the unit test. So V model is really giving importance to make sure the verification and the validation is correctly done in every stages throughout the life cycle. Okay, so that's why we are having the unit level, then we integrate become module level, then the module will be integrated become the system, and then this system need to be integrated, and then it will be followed by at the client side. Okay, so the next thing is, let's recall back what can be the advantages and the disadvantages of this incremental and non-incremental approach, because both of them, they have their own style how the integration will be done, how the testing will be conducted. So we want to do a little comparison to see the advantages and the disadvantages of these approaches and to decide which will be a better approach to use. Okay, so the first one, okay, if you see, just now we have talked about using this driver and stop. Okay, when we need to use this driver, when to use the stop. Okay, so for non-incremental approach, okay, they actually required more works. This is because in non-incremental approach, each of these module will be tested individually. So in that case, when we use non-incremental approach, we will need driver and also we will need stop. Okay, so this number is actually based on the diagram just now. So we will need both of them. We will need driver and we will need the stop. So in that case, if the more the coding is not being completed, the more we are going to create the dummy code to act as a driver, to call the lower level code, and to replace as to be the stop, which is replacing the lower level to be called by the higher level module. So for non-incremental approach, we need both of them. Okay, but for incremental approach, what will happen is we only need the driver or the stop. Okay, because when it comes to incremental approach, we have a strategy to choose. Either we want to use top down or we want to use bottom up. So in that case, I will only need either one. If I use top down, start from the main module to the lower level module, which one I will need? Driver or the stop? If I choose top down strategy, I start from the main module, move lower level. Which one I will need? Driver or the stop? The stop, because we have completed the higher level, so we need the stop to replace the missing code at the lower level. So when it comes to bottom up, it means we have completed the lower level and we might need a dummy code to replace the higher level so that this driver can call the lower level. So when we use incremental approach, we use the strategy either one. So we will only need driver or the stop. We don't need them both. So in that case, compared to non-incremental approach, it will require less work to prepare this dummy code. So which one is having the advantages here? Incremental or non-incremental? Which one is having the which one is having the advantage here? Incremental or non-incremental for this first point? Because we are discussing the advantage and the disadvantage, right? So which one is having the advantage here? Incremental, because we will require less work. Okay, so the second point, programming errors. For example, like any mismatch of the interface or any incorrect things happen during the integration of the module can be detected earlier in the incremental approach. This is because the module will be integrated with the next module much more earlier compared to non-incremental, where each of these module, they will not see each other until we combine them as a whole system. So when we already integrate them as a whole system, the complexity is actually there and it is considered very late. So whatever simple programming errors will be giving us big headache in non-incremental approach. So programming errors which can be detected earlier. It means one module with another module. We can already detect them. So when I combine these two modules with another module, I can detect them. But when it comes to non-incremental approach, all the five modules will be tested individually. Then I combine all these five together. So when there is programming errors happen, it is very complex for us to do the debugging later also. Okay, so due to this point, debugging activity is actually easier in incremental approach compared to non-incremental approach because in incremental approach, when we able to detect the programming errors earlier in a small size of integration between two modules, between three modules, not as a complete system yet, so the debugging process can be much more easier to be done. But in non-incremental approach, we will only detect them after they have been combined as a whole system. So the debugging will be much more complicated. Okay, so in that case, point two, point three, who is having the advantage? Incremental approach or non-incremental approach? Is it identifying the defect is better in an early stage or not? Yes, should be, right? Because we can identify it earlier, we can fix it easier. Okay, we might not spending a lot of resources, a lot of time, a lot of money there. Okay, so the advantages for point 2 and 3 will be incremental. Okay, let's see the next point. Actual modules receive more exposure by the completion of the last module task in incremental approach. So if you see in incremental approach, each of these module have go through more testing compared to non-incremental. So if you see incremental approach, every time the module has been integrated with another module, it will be tested again and again. So the first started module will be tested multiple times until we combine with the last module of the hierarchy. So in that case, the module is having a better quality when it go through many round of testing. But in another side, for the non-incremental approach, what happened? How many times each module will be tested? How many times each module will be tested in non-incremental approach? Lesser means how many times? Can we know the exact time or not? How many times each module being tested in non-incremental approach? Are you sure we don't know? I thought we know. Are you guys sure that we don't know? Yes, only two times. Because each of these module will be tested individually. So one time. So after done with the individual testing, we will combine it as a whole system and we will test for the second time. So for non-incremental approach, each of the module is actually tested only two times as an individual module as a system. So of course it is lesser compared to incremental approach, but we have a fixed number there compared to incremental approach. So the quality of the non-incremental approach might be lesser than the incremental approach. Okay, so the advantages for this point is going to the incremental approach also. Okay, the next point is machine time to execute is lesser for non-incremental approach. So it means since each of these module being tested only 2 times, okay, so the machine time which is used to do the test execution is lesser in non-incremental approach, while it will be more in incremental approach because every module go through testing many times again and again. So the machine time used for test execution in incremental approach will be more. Got it? Okay. But the machine time actually can be used for two purposes. One is for the test execution. One is for generating the stop and drivers. Remember? Just now we talked about it in the first point. So, since in our first point we already know non-incremental will be needing both of them. So what will happen is the machine time which is used to generate the stop and driver will be more in the non-incremental approach compared to incremental approach. Because in incremental approach, we will decide either we need driver or we need stop because we don't need both of them. So machine time which is used to generate this stop or the driver will be less in incremental approach. Can understand? So machine time has two different usage here. And for each of this usage, each of this approach, they have their own advantages. So machine time used for test execution is less in non-incremental approach. But the machine time used to execute this driver and stop, it will be more for non-incremental approach. So for the incremental approach, it will be on the opposite side. Because the test execution is more, so the machine time used is more. But the dummy code which is needed in incremental approach is less, either driver or the stop. So the machine time used to generate them also less. So there is one advantage point for incremental and one advantage point for non-incremental. Okay, then the next point is non-incremental approach can enable parallel testing activities. Since each of these module will be tested individually, so we can test them parallelly because we don't need to wait for them for any reason. So when it comes to incremental approach, okay, since incremental approach, we need to combine this module. So we cannot do parallel testing activity because we need to wait for one module to be tested first, then it can be combined. So until then, that particular module cannot be tested yet. So for point 6, the advantage is for non-incremental approach because it can allow the parallel testing activity compared to incremental approach. Okay, got it? Can understand? Okay, so that is the 6 points where we do the comparison between this approach and we able to know which approach is having the advantage. Now we want to finalize which approach is better. So in the summary, from the point 1 until point 4, the advantages was actually for incremental approach. Okay, you can check back what was the 4 points. Okay, then while the point 5 and point 6 actually disadvantages for the incremental approach, because non-incremental approach has the advantages. Okay, so let's see if this advantage and the disadvantage is really matter, and which one is having a better advantages. Okay, so in the current computing industry, okay, compared to years back, okay, hardware cost actually dropped. Okay, like my time before, pen drive is very expensive. Now it's very cheap. Okay, so hardware cost has been decreasing. Okay, so whatever advantages we discuss on the hardware side is actually not a big advantages anymore, because we are not spending a lot of money on this hardware part. Okay, so the when the hardware cost has been decreasing, hardware capability actually increase. Okay, it means the sizing, how it can support the storage, all this. So hardware capability increase, and labor cost, the people we need, okay, labor costs and the consequences of software errors are increasing. Okay, so when we able to identify errors defect earlier, okay, then it can actually lower the cost for the debugging, the cost for the repairing part. So in that case, through the point 1 to 4, okay, are growing importance compared to the point 5. Point 5 just now is the machine time. So this machine time advantages is really not playing very important advantage anymore. Okay, because usage of the machine time is not really a big amount of money anymore. Okay, because we will be spending money more on other things, which is like the labor cost to do the testing, to do the debugging. So in that case, point 5 becoming less important. And when it comes to the advantage of point 6 just now, which is enable the parallel activity, it's not really a big disadvantage for the incremental approach. Okay, so in that case, incremental approach is having better advantages compared to non-incremental approach. So if we have a choice to make, to use any one of this approach, then incremental approach will have better advantages. So it become a better approach to use. But let's assume if we have no choice, we must conduct using non-incremental, then we can use it. Okay, so for example, for your assignment, okay, because your assignment, you need to mention about this approach in your strategy later. Okay, so if you see the system which you are going to select for your assignment, are you the one developing it? Are we going to do the integration before we do the testing here for your assignment? Have you guys selected the system? So, is it your system? Are you the one developing the system? Is it the programming part still not complete? Or the system is already integrated? So you need to understand, so the system which you are going to use for your assignment purpose, it's not a developing system. It's not currently being integrating, but it is already integrated, and it is actually working as a system. So in that case, you need to know which approach or which strategy will be suitable to be used here. Got it? Can understand? So when you are explaining later, okay, you must not talk about stuff. You must not talk about drivers, because there is no missing code in the system you are going to test. So everything is completed, and you must not mention like you need this, you need to generate this driver, you need to generate the stuff when you are doing integration and so on. Okay, so please make sure you clearly understand how to discuss about this strategy later. Okay, got it? Clear? So you, for your assignment, you are preparing test plan. You are not preparing assignment report or coming up with stories. So there is no assumption in test plan. What you see, what you plan, what you are going to do, you will put directly, exactly, that is the test plan. So this is not like other courses assignment where you assume it can work like this, you assume it will be like this. No, there is no assumption. What you will do, what the system let you to do, that is what you are going to mention in your test plan. Got it? So it is very important for you to be clear about how to prepare test plan. So there is no lying, there is no anything which is not real in your testing later. Okay, so don't come up with any stories. Okay, got it? So clear about all this. So I have discussed the top down, bottom up strategy. Okay, this is just the example how each of the strategy work. So when it comes to top down, so we start from the A, and then we combine them with B, C, and D. Then we combine with the lowest level, which is E, F, and G. Okay, and when we use bottom up, so we start from the lowest one, which is the E, F, and G. Then we will be combining where E and F with the B, and then we have the C, and then we have the G combining with the D, and then we will be combining with the A. Okay, so that is about the bottom up and also the top down strategy. Okay, so this will be the advantages for each of the strategies. We have the advantages and the disadvantage for each of them. So in a overall way, okay, we will choose to use which strategy based on the completion of the code. Okay, so it means when I have completed by my main module, so I can start from top. But if I did not do my main module yet, because some project they like to do in that way, where they do all the lowest level functionality, the input output functionality first, then the last thing they will have their main module. So it's depend. So in that case, if we have completed the lowest level module, then we will choose the bottom up strategy. So the advantages of this strategy is where we have completed and we can able to find the flaws or to find the defect from that level. So if we use top down strategy, the advantages will be when the major flow happens towards the top of the program. So it means the code what we have done on the top, if it's giving us the error, sorry, the defects there, then it will be an advantage. So the same thing goes when it comes to bottom up, when the major flows happen at the bottom of the program or the software. Okay, so once the input output functions are added, it means the lowest terminal level of functionality has been added, then the test case will be easier to be represented. Okay, then since main module is always the backbone of the program, okay, so it will allow us to know exactly how strong is the is the software, so it can allow us to do the demonstration of the overall software. Okay, so let's see the advantages of the bottom up first. So the same thing, the bottom up, the advantages is when the flaws happen at the bottom part. So since we already have the input output function, so the test conditions will be easier to create. Okay, and we can also do the observation of the test result easier because we already have the functionalities, then we can already know what is the condition is going to do and what will be the test result. So this will be advantages of the bottom up strategy. So let's see the disadvantages of the top down strategy. So what will happen is, of course, if the code is not being completed, so for top down we must produce the stub. Okay, so because we need to replace the lower level code so that we can use the main module to call that. Okay, so it will be much more complicated than it will appear first. Then before the input output function added, so the test case which is using the stub can be a bit difficult to be represented. Okay, then the test conditions may be impossible and we might not able to identify the correct test output or result yet because we don't have the actual code, but with the stub maybe the correctness will not be as much. Okay, then for the disadvantages of the bottom up, so what will happen is we need to have the driver, so we need to produce the driver if there is any missing code happen. So until the driver, sorry, the main module is there, okay, the entity of the entire program or the backbone of the entire program does not exist. So it will be a bit difficult to control the program. Okay, so that will be the advantages and the disadvantages of both of the strategy. Okay, clear? Clear with this incremental approach, non-incremental approach, stop, driver, and then top down and the bottom up strategy. Can everyone? Any questions so far? Any question?
No question.
Okay, great. Okay, so it's okay, right? I can continue, right? So the next part will be the higher order.
Miss, I have a weird idea, but I want to ask, is it
Yes,
possible to combine both bottom-up and top-down strategy to make something like a sandwich strategy or something like
yes,
that?
yes, can. So
Oh,
it's actually not something fixed. This strategy, even to choose the bottom up or top down, it's something that depend on how the development is going on. So when you want to combine them based on how the development has been carried, yes, you can use the sandwich approach, the strategy.
interesting.
Mm-mm.
So, but if I were to suggest something like this as an answer in the final exam, would it be acceptable or?
Let's assume if because our syllabus here we did not cover about